Okay, if you don't have any doubt, then let us go ahead and let us see the converse of first. What was the statement I told you? That if xn converts to x, then we proved mod xn that converts to mod x. What about converse? Converse means what? If mod xn converts to mod x, then can I say xn converts to x? Correct? So can you give me a sequence where mod xn is convergent but xn is not convergent? Yes, have you seen this sequence xn equal to minus 1 raised to n? Is this sequence convergent? Yes, is this sequence convergent? Yeah. What are the limits? What are the values of this sequence? 1 minus 1, 1 minus 1. Can I, if my that is limit n tending to infinity xn, if I say, so can I surely say this will be 1, or can I say surely this will be minus 1? No, correct. So that means this is divergent sequence. Limit is having two values, 1 and minus 1, limit of this, correct? So this sequence is divergent. But what about mod xn? If I take mod of xn, can you hear me? Hello? What will be the mod xn? You see, it will be always 1. That means it is a constant sequence. Mod x1 will be 1, mod x2 will be 1, everybody will be 1. So here mod xn converts to 1, correct? But xn does not converge. Do you see? Something like you can write mod y. So that is what I give you the counter example. That is mod xn is converging to mod x, but xn does not converge to x. So that's why this is not true. This is only true when your x is 0, when the limit x is 0. Okay. Yeah. And what next? You proved that if an converges to a, bn converges to b, then question was, then you proved that en plus bn converges to a plus b. What about converse? That means addition of sequence convergence, and they are not convergent, either this or both are not convergent. Give me two sequences where addition is convergent but they are not convergent. Can you give me? Give me en and bn such that en plus bn is convergent. En and bn, they both may be divergent or one of them is divergent. Yes, can you give me? Can you give me en and bn? First of all, can you give me a divergent example of divergent sequence? What about en equal to n? Is this a divergent sequence? If you take limit n tending to infinity to n, so that is infinity, correct? Not that does not exist. So this is divergent. Do you agree? Okay, I should ask with somebody. You are not replying. So I will be taking names now. Okay. Do you agree this n equal to n? This is divergent. Yes, Lavanya. Rule number 33. Okay. Pratham, rule number 12. What can you say about this sequence En equal to n, whether it is convergent or divergent? Okay. Uh, Swetha, uh, perfect. Very nice. Very nice. Finally, I'm happy that you could realize the graph. You can tell that graphically that is divergent. Yeah, I'm here to. Don't worry. See, uh, En equal to n. To check whether it is convergent or divergent, what you have to do, you have to just see this, whether limit n goes to infinity and whether this is a number or not. Correct, this is what the question is. You need to find this limit, whether if I'm asking about convergence, then in short I'm asking about this limit, whether this limit exists or not. And you already know, whenever you are having limit something x tending to infinity, then you know that 1 upon x raised to m, that is 0 for m is positive, correct? Otherwise it is not defined. Do you agree? You have done that in your 11th standard. Whenever you are having extending to infinity, then you are having only one condition, that is 1 upon x raised to m, where m is positive number, then this will be 0, correct? Otherwise if you take any value, that is limit x tending to infinity x, if you take x, that means what? X will be 1 2 3. It is, you cannot specifically say that this converts to 5 or this converts to 10 or any value. So that is what limit. And graphically if I talked about, so if I say this limit is 5, so around 5 if I make a band, correct, around 5 if I make a band, then I see that I cannot restrict all the points. There will be points which will go away from that band, correct? I cannot restrict that. So that's why it is divergent sequence. Okay. And what about if I take bn equal to minus n, is it convergent or divergent? Perfect divergent, do you agree? And what about their addition? Zero, na? So zero is the constant sequence. That is convergent, correct? So do you see the counter example? Their addition is convergent, but they both are divergent. Do you see that? That's why this is not if and only if. We have proved an is convergent to a, bn is convergent to b, then an plus bn is convergent to a plus b. I wanted that their addition is convergent, but they are not. So I gave you an example. I took en as n, bn as minus 1, their addition is 0, then they are not. Can you similarly give for en minus bn? Give me en, give me bn, such that en minus bn is convergent, but they are divergent. Yes, anyone? Pratiksha, number 13. Can you give me en and bn such that their subtraction is convergent, but they are not? Very nice, nice. That is what I wanted. You can take en as n, and if you take bn as n again, then will this work? This will be n minus n, correct? The same technique. That's why I asked you the same question, that whether you are awake or not. Do you agree? This is divergent. This is divergent. Their subtraction is 0. So you are having subtraction is 0. That means subtraction is a constant sequence. Every constant sequence is convergent and converges to the same value, but they are divergent. Do you agree? Mhm. And one more thing we have proved. We have proved En is convergent, Bn is convergent. Then we have proved En into Bn is convergent. Now my question is, can you give me En and Bn such that their product is convergent, but they are not. This should be convergent. They are not. Can you give me En and Bn? I have already given you example in last 5 minutes. Just think about it. Their product. I am talking about product. Can I take En as n? So this is divergent. Do you agree? Yeah. Very nice. Very nice. Bn is 1 upon n. And do you agree this is convergent? And why this is convergent? If you take limit and tending to infinity 1 upon n, this will go to 0 as per we have seen this formula. Correct? So this is convergent, this is divergent, their product is 1, which is convergent, correct? So when you are having product is convergent, you cannot say they both are convergent, correct? When you are having product is convergent, you cannot say that they both are convergent. Okay, now one more question. Can you give me, I gave you one example where one of them was convergent, one of them was divergent. This was convergent, this was divergent. Can you give me En which is divergent and Bn is also divergent and product is convergent? This is quite tricky one. Think about it. Give me En which is divergent, give me Bn which is also divergent, but their product En and Bn that is convergent. Did you understand my question? Give me En which is divergent, give me Bn that is divergent, but their product must be convergent. Give me such A and Bn. Think about it. Observe one thing, in all the cases I have considered the product as constant. Here also you see, and here also if you take subtraction, I was taking a constant, and if I go here I was getting constant. So my focus was to make that guy as a constant value, then that will make my life easy. Now, can you give me En and Bn which are divergent but product is convergent? Anybody? Think about it. Okay, if you say 2 raised to n, that is divergent for sure, correct? But what about 2 raised to minus n? That is same as 1 upon 2 raised to n. Na? And what can you say about this sequence? If you take limit n tending to infinity, 1 upon 2 raised to n, correct? What can you say about this sequence? I already told you 1 upon कोई भी n का term आए, then that will go to 0 na, whatever it may be. Do you agree? You can check. Put n का value 1 put किया, then it is 1 by 2, 1 by 4, 1 by 6, 1 by 16, 1 by 32. It is going near to 0. Do you agree? Yatin? Yeah. Okay. Can you give me En and Bn? Both are divergent. Think about it. I have already given you an example which will help you. Okay. I'll just give you a hint. Can I take En as minus 1 raised to n? First of all, do you think that this is divergent? Yes, can I take this? Hello. Yeah, it is divergent. Why it is divergent? I already told you. Why it is divergent? I cannot choose a particular point that this will be always one. This will be always one only if your this power is even power, correct? But this is n, so it will be even or both. So I cannot decide that this will converge to one. This has two limit. But as per our proof, we have proved that if our if the limit of a sequence convergent, then the limit is unique. I hope you remember that proof. Then limit is unique. Unique means what? It should converge to only one value. But here we are having two options. It may converge to one also, minus one also. So that's why it is divergent. So once you are sure that this is divergent, can you give me a Bn such that their product is convergent? No, this should be easy. An is minus 1 raised to minus 1 raised to minus n. Okay, perfect. That is fine. Very nice. That is also okay. Minus 1 raised to minus n. Or else can I take minus 1 raised to n only? Again. Is that okay? What about the product? Product will be minus 1 raised to n the whole square. Do you agree? Now minus 1 raised to n कुछ भी हो, either it is 1 or minus 1, I don't care. Because in the power I am having 2, so answer will be 1. And you was also right that if I take minus 1 raised to minus n, that means what? It will be 1 upon minus 1 raised to n. Then also it is okay. Then also the product will be 1. Correct. Do you agree, everyone? So we are having two sequence en and bn which are divergent, but their product is convergent. Okay. Yeah, one more question. I proved that if en is convergent implies en is bounded. Can you give me the contrapositive? Oh, sorry, converse of this. Whether converse is true. Give me a sequence which is bounded but not convergent. Give me a sequence which is bounded but not convergent. Very nice. My en equal to minus 1 raised to n. Why this is bounded? Because it has en is always between minus 1 and 1. Correct? So this is bounded. It has bounded. It is bounded above and bounded below. So it is bounded and it is divergent. You already know that. Correct? Yeah, is that clear? Yeah. Now let us do one property actually, one theorem maybe you can say. Most of you must be aware of that. That is in bolo. Okay. En is convergent implies En is bounded. ये हम लोग ने एक theorem proof किया था. I hope you remember that. We have proved if En is convergent then En is bounded. Then my question is give me a sequence. इसका उल्टा होएगा क्या? That is my question. That means if I am having En is bounded, can I say En is convergent? And the answer is no, because I am having a sequence which is bounded, correct? But this is not convergent. Yeah. Okay. Now the most important one, that is sandwich theorem. तुम लोग के केस में हम लोग बोल सकते वड़ा पाव theorem. What is sandwich theorem? Or that is also called squeeze theorem. whatever you say. Let En, Bn, and Cn be three real sequences such that En is less than equal to Bn is less than equal to Cn for all n belongs to natural number, and you are given one more thing, that is limit n tending to infinity an, that is equal to L, and that is same as limit n tending to infinity Cn. That means this guy is converged to L, this guy is also converged to L. Then what should my conclusion be? Can somebody complete that? Then what should I say? This guy converges to L, this guy is also converging to L. So what should be my conclusion? Perfect, very nice. Limit n tending to infinity, Bn should also converge to the same value. That is squeezed, because Bn is squeezed between them. You can say sandwich theorem. Correct? These are the your pav and these are your vada pav type. Okay? Shall we prove? Let us start the proof. Correct? So you are what are you given with? You are given this part. That is En is less than equal to Bn is less than equal to Cn, and you're also given with limit n tending to infinity En equal to L, and this is also L. Correct? What should you do? First write the definition of this. You are given limit n tending to infinity En equal to L. Let me ask with someone. Hmm. Sakshi, rule number 21. Can you give me the definition? En converges to L. Epsilon delta. Epsilon and not definition. Rule number 19. Oh, sorry. Sakshi. Rule number 21. Can you give me the definition? Epsilon and not definition. Okay. Rule number 50. Hemang. Nobody. Sweta. Just tell me the definition of this. Oh, you are mixing that. No. For all epsilon positive, there exist and not below. Yes. Such that n is greater than equal to n naught. You are having some condition. So ये मैं बाद में लिखता हूँ. What is that condition? Mod of En minus. Yeah, here we are having En that is less than epsilon for all n greater than equal to n naught. Correct? This is the definition. Do you agree? Uh, since I am having En and Cn, so I'll write n1 here. I'll not write n naught. I'll write n1 and here also. Correct? Now, can you similarly give me the definition of this limit n tending to infinity Cn equal to L? Can you give me the definition of that also? Yeah. Yes. Such that. Correct. Good. Okay. Now, my condition is that I want to choose a single n Here I'm having n1, here I'm having n2, I'm having two n1 and n2. I want to choose a single n which should work for both of them. If you are present in my last lecture, then you must answer this. I'm asking with everyone.